Day 1. Trebuchet. Something is wrong with the global snow production, and you've been selected to take a look. The elves have even given you a map. On it, they've used stars to mark the top 50 locations that are likely to be having problems. You've been doing this long enough to know that to restore snow operations, you need to check all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck! You try to ask why they can't just use a weather machine, not powerful enough, and where they're even sending you, the sky, and why your map looks mostly blank. You sure ask a lot of questions. And hang on, did you just say the sky? Of course, where do you think snow comes from? When you realise that the elves are already loading you into a trebuchet, please hold still, we need to strap you in. As they're making the final adjustments, they discover that their calibration document, your puzzle input, has been amended by a very young elf who was apparently just excited to show off her art skills. Consequently, the elves are having trouble reading the values on the document. The newly improved calibration document consists of lines of text. Each line originally contained a specific calibration value that the elves now need to recover. On each line, the calibration value can be found by combining the first digit and the last digit, in that order, to form a single 2-digit number. In this example, the calibration values of these 4 lines are 12, 38, 15, and 77. Adding these together produces 142. Consider your entire calibration document. What is the sum of all of the calibration values?
So let's start by breaking down the requirements of this challenge. So the ultimate goal for us is to get the sum of all the calibrated values. So in our case, it would be for this sample snippet would be 142. Fantastic. And how do we get this 142? We actually need to look at all the specific calibration values. So in this case, it might be the full string. And we need, from that value, we need to find the first digit and the last digits. This will be a number, a specific number, and these are concatenated together to make a 2-digit number. And if you look at different use cases, we can see this where we take the first number, which is a 1, and then the last character 2. There can be X number of content in between these specific values. So it could be all ABC, or it could be like any number of stuff before and after this in this string. And that 1 and 2 equals a 12. And that will be as part of our 142. And it's the same for the second one, which is like we need to pull this 3 out and we need to pull this 8 out with some prefix and suffix stuff. And then the third one, which I think is the interesting use case here, is that we take this first, we actually have a 1 as the first, but we also have another digit as a 2. So we can't just go after you found the first number, like the second number, if you find one, use it. We can't do that. But it can be X number of numbers in between as well. And then there's also the 5 at the end. So this would become 1 and 5, which equals 15. And then the last one is where we have the first value and the last value is the same number as well. So really straightforward. And we need to sum these together just to get that 142. So I've gone and done the liberty of adding this into my Rust project just as some inputs. You can see here, day 1 inputs. I was actually able to also download the full day as well. And then we can start writing our actual code as well. So after I copied over the Rust sample snippet here, you can see that we're just printing out the value. When I write the code, there's a cargo watch at the bottom here where we can actually see exactly the content that it's being produced. In our case, you can see here that the input is outputting to the console. So let's break down each of these problems. So the first thing that we need is the final result needs to be a sum of all of the calibration values. So we will actually create a new variable. Let's just call it total. We actually want to set this as a mutatable value as well, because of course we'll be updating this as we go. And in Rust, all variables are actually immutable, which means you can't change them. but you actually use mut to actually signify that this will be changed. And this is like just an I32 value as well. And as we're going through this as well, I will add a quick total here. And then we're just going to print out the total, or you can actually just use this inline format string. So if we save that, we can see now the total is equal to 0. If we update this as well, you will see this changes to 1. And there we go. So we'll set that to 0. So let's start splitting this problem into its individual components. So the first thing that we need to do is actually look at each of the lines individually to actually find the specific calibration value. So let's do this by actually iterating over every line in our input, where we can actually split out and use a function called lines that's part of the string library. And this actually allows us to iterate over each of the slices of strings in our input. So let's take this and do and print this out. So just to kind of showcase what this will look like as a line. And what we can actually see here is that now we're actually showing each of those individual lines. So fantastic. Let's remove this now and start actually solving this problem. So the first thing we need to think about is we need to obtain the first and the last digit in that specific order. Okay, how do we do this? Now, there's a couple ways of doing this, but the easiest way I'm thinking of is maybe I want to use maybe a vector or an array to store each of the characters, or each of the numbers, I should say, that are in my input that I care about. So let's start by this. Let's create a new stack here. Let's actually explicitly set it to an I32. Here we go. And create a new vector in Rust. So kind of like an array in Rust, but it's a little bit different. But what we can now do is start really using some of the really amazing built-in functionality that Rust provides. There are so many of these APIs out there that just make your life so much easier, and you should really consider looking up the docs if you want to do some of these kind of string parsing problems. In our case, what we're going to do is actually look at the line. This is a string slice. And what we're going to actually do is use the chars function. So what this will do is it will return an iterator it will iterate over all of these chars of this string slice. So what we can do then is actually combine this with other functions that we can to iterate over and produce this stack for us. So in my case, we can actually use a bunch of filters, a bunch of functions like filter, or maybe find or map. And there's so many of these amazing iterative functions. Definitely take a look at them. But what we're going to use today is filter. This requires a predicate. So it's a predicate where you provide it and you have to return a boolean that is the kind of filter on the values that you want to iterate over. In our case, we get a reference to a char, and there's actually some really awesome functionality in char that is exactly what we need. In our case, we need to find a digit or a number, and there's actually a really powerful function in Rust that actually returns you exactly what we want. Is this character numeric? And what happens is that if you carry on and we do something like a for each loop, and this is another function as well where maybe we're taking out a char, we can actually print this out, and hopefully this will only print out the specific characters that we want. So in our case, char, and I'll add a semicolon there. It's going to reformat it for me. That's fine. And we can see that the output is actually all what we need. We need the 1, we need the 2, we need the 3, we need the 8, and then you can see the 1, 2, 3, 4, 5 from the third input. They're all here as well. But that's not exactly what we want. What we actually want is to take this char and actually add it to our stack. Now, some of you might already be thinking like, oh yeah, I can actually cast this char, for example, into an I32. But actually, that's not the case. So if we actually try this now, so let's take a stack and we push it. I always think it's going to be an append, but it's actually not an append in Rust. It's actually a push for vectors. That might be from writing a lot of Python code. We're going to use push to push something to this specific stack. And if we did a char, this will actually give us a compilation error. In our case, we'll actually get it so it's like a cast to I32. But this is actually not exactly the case. So it's saying down here, char needs to be like cast to an I32, and this will solve our problem. But if we do this, let's actually look at the output of this. So we need to add a semicolon there. Let's always forget that. And let's actually print this stack value for us. So we're going to just use this. You need to do that format string for vectors. And let's actually see what the output of this is. And it turns out that it's actually casting that byte, that char, to its specific numeric value, or that like I32, but it's actually not what we want. What we want is actually the actual digit of this. So in our case, there's actually a really neat function, and I always forget it for chars, so do like look up the library for char, or the module for char in the documentation. But there's actually a really amazing function called I always forget it's called 2-digit. So this is actually looks at this specific number, so we filter it by numbers and it's numeric, and then we need to cast it to a digit. Now this actually returns, if you try this, it will also say that, hey, actually this is an option, not an actual digit, because of course this might actually not be a number when you cast char, so it's actually worth like doing some filtering. I'm actually going to just unwrap this because I already know this is a numeric char, so I actually don't care. But of course, you want to do this in a safe way as well and actually like handle this specific use case. It might be where you do maybe an else, or maybe you just provide it back a 0 or something like this. That could help as well. But I'm going to just unwrap it. But even if we unwrap it, you'll see the next problem, which is when you this is actually an option for a U32, but we actually need I32s. So we could change it up in the stack here, but I'm actually not going to do that. I'm actually going to cast it using a I32 here, and we're going to run this now. And I always like it when you remove that, and it makes it pretty print for us as well. So you can see here now we have these 4 stacks, one of 1 and 2, the next one of 3 and 8, the next one of all the digits from the third one, and then just a 7 here. Now that we have this stack of I32s, so these integers, let's now actually like build up a string with these values. So let's take a mutable string. I'm going to call it result, and I'm going to create a new string. Now, I think there's a better way of doing this. I'll refactor it towards the end, but I think this is just really simple and straightforward, where maybe we're doing something like result.push string. We want to look at this specific stack value, so we'll do stack.first, for example. We need to unwrap this, because if you actually look at first, it gives you an option, because this, of course, could be empty, for example. So let's do that. We will just say that we guarantee that there's something there. That's fine. And then we can cast this to a string. So if we now save this, and of course add a semicolon here, let's double check that. We need a reference to stack, because it doesn't take ownership of stack. And now we will get that first value. Let's now yank that and take the exact same thing, but we can use the last function in here, run the same thing. And then here we can do a quick print line. So let's just add something like results like that. And let's have a look at what that looks like. Okay, fantastic. So this is a 12, like 38, 15, 77. Fantastic. And then, of course, the last thing that we need to do is actually add this to our total. So in our case, it would be result dot, I believe it's the parse function. So in Rust, there's a really awesome parsing built in. But if you try to just use this by itself, it doesn't actually know what type it's trying to parse into. And of course, this needs to be an integer. So we can actually use the turbofish syntax to actually allow us to say how are we parsing this, and how is it working, and why is this not working? Implementation for this is incorrect. Now, what is this error? Of course, it's a type error, because of course, when you're parsing it, this is actually returning a result type. We can see it here. So it could be a parsing int error, or it could be an I32. So we actually need to either unwrap, or we can just use question mark here to like unwrap for us. And now we get these values. So let's remove some of these print lines right now and just show the total. In our case right here, it will be 42. Awesome. Now let's actually try it with the real input. So let's type in here full day, for example. Okay, 55,017. So let's take a copy of that. we'll go over to Advent of Code. I'll bring that over here. Let's put in this value. And fantastic, we have the right answer, and we've earned our first gold star of the day.
Part 2. Your calculation isn't quite right. It looks like some of the digits are actually spelled out with letters. 1, 2, 3, 4, 5, 6, 7, 8, and 9 also count as valid digits. Equipped with this new information, you now need to find the real first and last digit on each line. In this example, the calibration values are 29, 83, 13, 24, 42, 14, and 76. Adding these together produces 281. What is the sum of all of the calibration values?
So it turns out that our calculation isn't quite right, and it seems that actually as part of that input that we were taking in the first part, it turns out this could be specific numbers that are actually spelt out with actual letters. So like 1, 2, 3, 4, etc. And we need to actually be able to also handle these. So let's take an example, or take the first example, where we have 2, 1, 9. So this means that this actual first line is 2 because of the actual characters that spell out 2. And then there's also 9, which is the last bit of 9. And the other interesting thing around this as well is that there can also be partial things. So like, for example, here, it looks like there's an 8, but there's technically also a 2, and there's 10, and there's also a 3. But in this case, we only care about the 8 and the 3. So we can't do something, for example, iterate through 1, 2, 3, and then, for example, the first time we iterate through, we say, okay, add to our stack of 2. Oh, turns out that there's an 8 before that, and then there's a 2. So we won't need to change the code too much, but there's certain things that I'll add just to make it a bit easy. So the first thing we need to do is actually add a mapping. So I've just added this constant mapping at the top of our application. This is just to make it easy, so when I'm looking for a 1 or a 2 or 3, etc., I know what the mapping corresponding for which number we need is an I32. So from here, this is quite easy. We have our code here that looks for specific numerics, but we also need to look for the specific case where this is actually a char or a string that matches like 1, for example. So I'm going to just comment out this code for now. We're going to, instead of using our iterator, we're actually going to be using our, a for loop here, just to make it a little bit easier for me. You can do this without, but I've decided that actually this would be easier to read. But we can do a quick if char is numeric. Then what we want to do is take our line here, paste back in here, and actually we want to remove all the bits that we don't care about and the end. And if we save this, we can go back here and make sure it compiles. Okay, it does, but let's comment back in that print line. And now we can see that it's starting to create some stacks. In our case, it's adding back the 1, which in our first case is 219. But of course, the 2 and the 9 are both actual words instead of numbers. And then of course the next stack is actually there is no numbers in there, so it fails. And we do get a panic because we do have, in both these two cases on this line here, we can actually see that it does require at least one element in that vector. So let's take this now and then add support for strings as well. So there's a few ways of doing this. I actually thought of a really interesting way of doing this using the ability to look at the current line, in our case this line, and we want to look at the current index, and we want to look at, in our case, everything after that specific index as a string. So there's a really nice way of doing this, which is actually using the let sum in an if statement here, and we actually want to do it for, in our case, we're going to call it rest of line, and then here we're going to do something like line.get. So there's a really good, and I definitely recommend this, you look at using get or get mut or on these other ones instead of using slices. I find that it's nicer because if you do make a mistake, in a lot of these slices, it will actually panic the application, where in our case, maybe we want to get a specific thing. What we want is actually the index. So we take the index, but we also want to add these 2 dots here. So this means from the current index all the way to the end as well. And if there is a case where this actually fails, it will actually skip over to the else statement. So now we actually have this if statement, and we get this rest of string. We can actually print line this just to see what this looks like. Rest of line, we'll add the semicolon there. So if we print this now, we should start seeing all the rest of the line as we go away as well. And the really nice thing about this is if we remove this now, we can actually do a quick mapping. So we're going to call this something like number string or something like this. And we're going to also use the actual raw number. And this is actually going to come from our mappings here. So we are iterating every time over this vector here. I'm not a big fan of this. This could be more effective, but we're going to just do it to get this problem solved. And of course, if we actually do a quick check of rest of line, it starts with our number string here. This if statement here will actually give us the value of, we can add to the stack where we want to push to the stack this number, for example. So if we run that now and we wait for it to run, here we go. So our output now is 219. So this is equivalent to what we had before. We can see here the 219, 219, and it actually equals to 29. And it's the same for 823 and all the rest of them as well. And as long as this total number is equal to this, we can now submit it. We can actually now run this with the full part now and run that. And we actually get this new number, which is 53539. And we can copy this into the challenge and submit it and see if this is correct. And awesome, we can finally now say that we've completed the first day of Advent of Code of 2023. Please join me tomorrow for the next part in this series. Thank you very much and have a great rest of your day. Take care.